are watching Darasa Online.
Hello student, this is Darasa Online. My name is Edgar Mshana. I'm teaching basic applied mathematics. Today we are going to review some questions from the topic of algebra. And in this topic of algebra, we are going to discuss some questions in the subtopic of simultaneous equation, that is one, but the second one will be finite and infinite series. My dear student, join with me till the end of this presentation. Welcome. Now, my dear student, here we have a review question. That is question number one. It is a word problem that is going to lead us in a simultaneous equation. Let us read the question. There are two numbers such that their sum is 10 and the sum of their squares is 52. Find the value of the two numbers. My dear student, this is a word problem. Let us join with you and see how we are going to solve such kind of equation. Join with me and see how are we going to solve such kind of a word problem. Now solution, here we have a solution. First step, we just let some letters, let x and y be the numbers, because numbers are unknown. So we let x and y be the numbers. So there are two numbers such that their sum is 10. That is, let's say x plus y is equal to 10. Call this equation 1. That is equation 1. But again, the sum of their squares is 52. That is the sum of x squared plus y squared. This one is equal to 52. Now call this equation 2. This is going to be equation 2. Now, my dear student, we have two equations. Let us see how are we going to solve such kind of a simultaneous equation. Now, using equation 1 above. We just start with equation 1 above. That is x plus y is equal to 10. At this point, you just decide either to make x the subject or y the subject. Now suppose we make y the subject. So we are going to have y is equal to 10 minus x, because we just shift x in our right hand side. So call this equation 3. Call this equation 3. Now we're having three equations. Now this time we take equation 3 and substitute into equation 2. So here we just say substitute equation 3 into equation 2. Substitute equation 3 into equation 2. So we are going to have, that is x squared plus y squared is equal to 52. But remember, y is equal to 10 minus x. So we say x squared plus, now y become 10 minus x. So we are going to have 10 minus x squared, which is equal to 52. So this is 52. Now we are supposed to expand 10 minus x squared as x squared plus 10 minus x. But again, we have 10 minus x is equal to 52. Just expand 10 minus 2. We times 10 minus 2 times 10 minus 2. Now, what are we going to get So we are going to have x squared that is x squared plus, now we just take 10 times 10, that's going to be 100. Then again, you take 10 times the negative x, we are going to have negative 10x. But again, we have negative x times 10. So again, here we have negative 10x. And the last one is negative x times negative x, which is going to be positive x squared, which is equal to 52. So here we have 52. Now, my dear student, we have negative 10x, negative 10x. So we just add these numbers. So we are going to have, of course, we start with x squared plus x squared, which is 2x squared, then plus, we have 100, then minus, we have negative 10x, negative 10x, that is 20x, which is equal to 52. So we are going to have 2x squared minus 20x plus 100. Now we shift 52 in our left hand side, so it's going to be minus 52 is equal to 0. Now we are going to have 2x squared minus 20x plus, here we have 100 minus 52, which is going to be positive 48 is equal to 0. Now, my dear student, here we can divide by 2 in each term. So just divide by 2. So just divide by 2, divide by 2, by 2. So we are going to have x squared minus, here we have negative 20x divided by 2, which is going to be negative 10x. Again, plus, here we have 48 divided by 2. This one is 24, which is equal to 0. Now, here we have a quadratic equation. You can use your scientific calculator to find the possible values of x. Now, just take your calculator and find the values for that quadratic equation. Now, the answers are, so x is equal to 6, or we have the second value of x, which is equal to 4. We have two values of x. Now, my dear student, we can use equation 3 to find the possible values of y, because now we have values of x. Now it is simple to find the values of y. Now, using equation 3, that is using equation 3 above, that is, we have y is equal to 10 minus x. Y is equal to 10 minus x, but we values of x. So it's just a matter of substituting values of x. Now, that is when x is equal to 6, we are going to get the first value of y. That is, y is equal to 10 minus 6. So y will be equals to, that is 10 minus 6. Here we are going to have 4. And again, when x is equal to 4, that is when x is equal to 4. So we use the same equation, that is y is equal to 10 minus 4. That is 10 minus 4. So y will be equals to 6. Now, my dear student, we have values for x and values for y. Therefore, we can conclude by saying that is by saying that is x comma y is equal to, so starting with the first value of x is 6, that is 6. When x is 6, y is equal to 4, that is 6 comma 4. Or again, when x is 4, that is 4 comma y, that is equal to 6. So here we have 6. Now, this is the solution for such kind of a problem. Now, my dear student, let us proceed to the second word problem. That is question number 2. We have the review question number 2. Now, which says the sum of two whole numbers is 5, and the difference of their squares is 5. Find the two numbers. That is our second word problem, which is going to lead us in a simultaneous equation. Now again, dear student, proceed with me to see how we can solve these word problems. Now the first step, we have to interpret the question by saying, of course, this is the solution. Again, just say let x and y be the numbers, because the numbers are unknown, and we have two numbers. Now the question says the sum of two whole numbers is 5. So we just say x plus y is equal to 5. That is the first expression, but again, and the difference of their squares, that is x squared minus y squared. Again, this is equal to 5. So again, here we have 5. So my dear student, you have a simultaneous equation. Now take equation 1, that is take equation 1 above, that is x plus y is equal to 5. Now it is your decision either to make x the subject or y the subject. Now suppose we make y the subject. So we are going to have y is equal to 5 minus x. Now call this equation 3. That is equation 3. Now we have 3 equations, equation 1, equation 2, and equation 3. Now this time we substitute equation 3 to equation 2. So here we just say substitute equation 3 into equation 2. Now what is the equation 2? Equation 2 says x squared minus y squared is equal to 5. So we substitute the value of y. So we are going to have x squared minus, so we have y squared, which is the same as 5 minus x squared is equal to 5. That is equal to 5. Now let us expand this expression. We are going to have x squared minus, so that is 5 minus x, but again 5 minus x, which is equal to 5. Now on expanding this, we are going to have x squared, then minus, so we just expand now, which is going to be, that is 5 times 5, we are going to have 25. Then we have 5 times negative 5, that is negative 5xc. And again, we have negative x times 5, that is negative 5x. And the last term is negative x times negative x, which is positive x squared. Now this one is equal to 5. So here we have that is 5. Now let us open the brackets. We are going to have x squared minus. So now before opening the bracket, let us add negative 5 and negative 5. So we're going to have negative 25 minus 10x plus x squared is equal to 5. Now we open the bracket. That is x squared minus, we have 25, but here we have negative times the negative, that is positive 10x. And we have negative times positive x squared, that is negative x squared is equal to 5. Now we have x squared minus x squared, that is 0. So we are going to have negative 25 plus 10x is equal to 5. That means we have 10x minus 25 minus 5, which is equal to 0. That is 10x minus 30 is equal to 0. So we have 10x is equal to 30. Now on dividing by 10, we are going to have, that is 10 divided by 10, we have x is equal to 3. Now we have the value of x. It is now simple to find the value of y, because we have equation number 3, which says y is equal to 5 minus x. So here substitute the value of x. So we are going to have y is equal to 5 minus 3. So we have now y is equal to 2. That is 5 minus 3. Now, my dear student, we have now values for x and the value for y. Therefore, we say the required number, that is the numbers, are, the first one is 3, while the second one is 2. So, my dear student, we proceed with the second subtopic, of course, we call series. In series, there are two types of series. Number one, we have finite series, and the second one is infinite series. Now, what is the meaning of finite series? Finite series is a summation of limited number of terms. So the number in finite series are limited. It means are countable. You can count them. But for the case of infinite series, they are uncountable. It means you cannot count the terms which are in infinite series. Now, my dear students, let's proceed by solving some of the review questions concerning to finite series and the infinite series. And we are going to see how to apply the sigma notation.
You are watching Darasa Online.
So, my dear student, we have a question which says, prove that the summation of k squared plus 2k minus 10 is equal to 10. Prove that the summation of k squared plus 2k minus 10 is equal to 10. But your starting point is when k is equal to 1 to 4. Now, such kind of equation is simple, and I will show you how to solve such kind of equation, how to prove. So we are going to substitute values of k from 1 to 4. That is, when k is 1, that is when k is equal to 1, so we substitute the value of k. So we are going to have, that is 1 squared plus 2 times 1 minus 10. Now this one is going to give us, that is 1 plus 2 minus 10, which is equal to negative 7. That is when k is equal to 1. So again, when k is equal to 2, That means we substitute the value of k in our equation. So we are going to have, that is 2 squared plus 2 times 2 minus 10, which is the same as, that is 4 plus 4 minus 10, which is equal to, here we have 4 plus 4, that is 8, minus 10, we are going to have negative 2. But again, we proceed with when k is equal to 3, because we go up to 4 when k is equal to 4. So when k is equal to 3, so again we are going to have 3 squared plus 2 times 3, then minus 10, which is equal to, here we have, that is 9 plus 6 minus 10. So we have 9 plus 5, that is 15, minus 10, we are going to have 5. Then the last number, that is when k is equal to 4. So when k is equal to 4, we are going to have, that is 4 squared plus 2 times 4 minus 10. So here we have 4 squared, which is equal to 16, plus, again we have 2 times 4, that is 8, then minus 10. Remember, we have 16 plus 8, that is 24. Minus 10, we are going to have, that is 14. Now, let us add these numbers to see if we are going to end up with 10. So now, we can say that is, now we have, the first one is negative 7, then minus 2, then we have plus 5, then plus 14. So here we have negative 7 minus 2, that is negative 9, then plus, so here we have 5 plus 14, that is 19. So here we are going to have negative 9 plus 19 is equal to 10. Therefore, it is true that this expression is equal to 10. So we say summation of, that is when k is equal to 1 to 4, we have k squared plus 2k minus 10 is equal to 10. That is hence proved. Now, my dear students, let us proceed with the second example concerning to sigma notation. And this time we have a question which says, that is example 2. We have example 2. The question says, represent, that is represent the following series, in sigma notation. Represent the following question in sigma notation. That is, we have A, of course we have 1 plus 2 plus 3 plus 4. Of course this one proceed to infinity. And of course we have B, we have 1 plus 4 plus 9 plus 16. Now, my dear students, let us see how we can use the sigma notation to represent the given series. So for the first case, we start with the sigma notation. Our sigma notation is written like this. So remember, this series has no end point. So our starting point can be k is equal to 1 to infinity. Why? Because there is no end point. That is infinity series. Now this number is just writing k. Because when k is equal to 1, then we have 1. Again, when k is equal to 2, we have 2. Then they proceed that way to infinity. But for the second case, this has end point. So it is a finite series. So in sigma notation, can be written as starting with k is equal to 1 to, we can count these terms. We have 1, 2, 3, 4. So proceed up to 4 when k is equal to 4. But these numbers, the given numbers, are the square of some numbers. For example, 1 squared is equal to 1. 2 squared, that is equal to 4. Again, you have 3 squared, that is 9. 4 squared is equal to 16. So it's the same as k squared. That is k squared. That means when we have 1 squared, that is 1. Again, when we have 2, when k is equal to 2, 2 squared, that is 4. Then to proceed up to 4. So that is how to use a sigma notation to write the given series that is in sigma notation. Now again, my dear student, let us proceed with arithmetic progression. Arithmetic progression. Here we are going to review a question, and the question says the fifth term of an arithmetic progression is 6 times the second term, and the sum of the second and the third term is 11. Find the first term, the common difference, and the sum of the first 10 terms. Now proceed with me and see how we are going to solve such kind of a problem. So in our question, the question says the fifth term, suppose we have that is A5. That is the fifth term of an arithmetic progression is 6 times, that is 6 times the second term, that is A2. But again, the sum of the second and third, that is A2 plus A3. The sum of the second and the third term is 11. This one is equal to 11. Now we have to find the first term, the common difference, and the sum of the first n terms. Now remember the general formula for nth term of an arithmetic progression, which says an is equal to a1 plus n minus 1 times d. Where an, that is the nth term of an arithmetic progression, a1, that is the first term, n number of terms, and d, that is common difference. So starting with a5, so a5, that is a5 will be equals, by using this formula, that will be a1 plus, now we have n minus 1, that is 5 minus 1, that is 4d. Again we have a2, so a2 will be equals to a1 plus, remember n is 2, 2 minus 1, that is 1 times d, we have d. But again we have a3, so a3 is equal to, we have a1 plus, our n this time is 3, so 3 minus 1, that is 2d. Now let us substitute in our equation. So the first case will be a5, that is a1, a1 plus 4d, that is equal to 6 times a2, but a2 is a1 plus d. That means you are going to have a1 plus 4d is equal to 6a1 plus 6d. So just collect like terms. We have, for a1 it will be a1 minus 6a1, that is negative 5a1. For d, we have 4d minus 6d, that is negative 2d. This one is equal to 0. Or the equation can be written as 5a1 plus 2d is equal to 0. My dear student, call this equation 1. So this is equation 1. But again, with another item here, a2 plus a3 is equal to 11. Remember, a2 is equal to a1 plus d. That is a1 plus d. Then plus a3. Our a3 is a1 plus 2d. Again, this is equal to 11. So here we have 11. So we have a1 plus a1, that is 2d. A1 plus, remember we have D plus 2D, that is 3D. So this is equal to 11. Now, my dear student, call this equation 2. Now we have two equations, equation 1 and equation 2. So let us put together, that is 5A1 plus 2D is equal to 0, that is equation 1. And equation 2 is 2A1 plus 3D is equal to 11. So look like a simultaneous equation. So let us solve this simultaneous equation. We can exchange the coefficient of A1. We have 2 and 5. So that is on multiplication, we are going to have, that is 2 times 5, we have 10A1 plus 2 times 2, that is 4D, which is equal to, that is 0. 2 times 0 is 0. And again, we have 5 times 2, that is 10A1, plus, again, we have 5 times 3D, that is 15D, which is equal to 5 times 11, we have 55. Now, we have numbers which are the same. So these numbers are positive, so we subtract 10A1 minus 10A1, that is 0. Again, we have 4D minus 15D, that is negative 11D, which is equal to, we have 0 minus 55 is negative 55. So divided by negative 11, now we have D is equal to 5. So we have the common difference. Now, what about the first term? We just choose either equation 1 or equation 2. It's going to give you the first term. So let us use equation number 1, that is 5A1 plus 2D is equal to 0. Remember, we have D, so we substitute, that is 5A1 plus 2 times 5 is equal to 0. So 5A1 plus 10 is equal to 0. So 5A1 is equal to negative 10 divided by 5. By 5, we have A1 is equal to negative 2. So for the first equation, the first term, so we have the first term, called A1 is equal to negative 2. But again, 2, we have to find the common difference. So the common difference, that is, and the common difference called D is equal to, we have 5. Now we remain with the only one question, that is the sum of the first 10 terms. So that is so the sum of the first 10 terms, that is S of 10. We need to find S of 10 is equal to how much? Remember the formula for finding the sum for arithmetic progression, which says SN is equal to N over 2 bracket of 2A1 plus N minus 1 times D. That is the general formula for finding the nth term, the sum of the arithmetic progression. So we have, that is S of 10 is equal to, then we have N over 2, that is 10 over 2, bracket of 2 times A1. Remember, A1 is negative 2. So it's 2 times negative 2. Then plus, followed by N minus 1. So we have 10 minus 1, that is 9, times common difference, that is D. D we have 5, that is 5. So, my dear student, we are going to have, that is 10 over 2, that is 5. Then we have negative 4. Then plus, we have 45. So that is 5 times. Now here we have negative 4 times plus, negative 4 plus 45. That will be 41. So we have 5 times 41. That will be 5, then 5 times 4, that is 20. Therefore, SC of 10, the sum of the first 10 terms will be equals to 205. My dear student, that is how to do such kind of review question concerning to arithmetic progression. Now, what about geometric progression? We have another review question for geometric progression. That is geometric progression. The question says, the sum of a certain number of terms of GP having first term 1 and the common ratio 2 is 255. How many terms are there? That is our question. So remember, that is a geometric progression. So solution, we have been given the first term of the geometric progression, that is called G1. G1 is equal to 1. And again, we have been given the common ratio, that is 2. So we have R is equal to 2. But that is the sum. We have the sum of a certain number. The number is unknown, so call it N. This is equal to 255. So what is missing is N. What is missing is N. The question says, how many terms are there? That means we are going to find the value of N. Now remember the general formula for sum of a geometric progression, which says SCN is equal to G1. Then we have Rn minus 1 bracket over R minus 1. That is when R is greater than 1. When R is greater than 1. And of course here R is greater than 1. Now let us substitute these values. SCN is 255, which is equal to, then we have G1. G1 is 1. Then bracket of, we have R raised to N. R is 2, so it is 2 raised to N minus 1 over, then we have R minus 1, that is 2 minus 1. So, my dear student, we are going to have 255, which is equal to, then we have 2 raised to N minus 1 over, of course, we have 2 minus 1, which is equal to 1. So, this was going to be 255. This is negative, so plus 1 is equal to 2 raised to N. So 255 plus 1 is 256, which is equal to 2 raised to N. Or say 2 raised to N is equal to 256. Now, here the base is 2. You can try to simplify this number by using base 2. Remember, we have 256 by 2. Of course, it is 128. By 2, we have 64. By 2, we have 32. 2, we have 16. 2, we have 80. 2, we have 4. 2, we have 2. And 2, we have 1. Now, how many 2s are here? You can count them. Of course, we have 1, 2, 3, 4, 5, 6, 7, 80. Therefore, 2 raised to N is equal to 2 exponent 80. Now remember, here we are having the same base. Our base is 2. One is in left-hand side, the other in right-hand side. Now, equal base implies equal exponent. Therefore, N is equal to 80. Now, how many terms are there? So the number of terms, we say the number of terms, are 80. So we are having 80 terms and this is geometric progression. Now, my dear student, we've seen the review questions concerning to algebra. The first part was solving simultaneous equation, and we were having the word problems that lead to simultaneous equation. But again, we proceed with the finite and the infinite series. The use of sigma notation, the arithmetic progression, and the geometric progression. Now, if you have a question or comment or suggestion, just send your SMS via my phone number, which is displayed on your screen. Otherwise, have a nice day. Till next time, join with me again.